Assalamualaikum warahmatullahi wabarakatuh. And very good day. So this is we are still in the topic one, AC power, but this lesson is for week two. Okay, we are currently at week two. So the topic is apparent power and complex power. So after completion of this lesson, the student should be able to differentiate apparent and complex in AC system. So just for a revision from the past week lesson, so right now we have already know what we call instantaneous power. So instantaneous power can be write down as a P plus P cos 2 omega plus, should be minus minus Q sine 2 omega. Okay, so where P is actually, you can calculate equal to 1 over 2 Bm Im cos theta V minus theta I, while Q is 1 over 2 Vm Im sine theta V minus theta I. Okay, but we can also define, we can write this equation of average power and the reactive power in terms of RMS value. So we know that VRM, so the VRMS is equal to Vm over square root 2, and also IRMS can be calculated based on Im over square root 2. So based on this relationship, we can actually write down our average power in terms of RMS value, such as VRMS, IRMS cos theta V minus theta I, while for the reactive power, it is VRMS, IRMS sin theta V minus theta I. And I would like to also revise or recall again that the unit used to measure the average power is called watt, while for the reactive power is called bar. And Q can be either positive. It is either positive in that your circuit is actually inductive, and if your Q is negative, meaning that you have a capacitive. Okay, capacitive circuit. Okay. So that is the revision. So this is actually the new lesson for this week. So what is apparent power? So apparent power, or sometimes also, usually we define as, is actually the product of the RMS values of voltage and current, which is S is actually just simply is a product of VRMS multiplied with the IRMS. So that is the apparent power. And the unit used is VA. Okay, the unit is actually VA. Okay, it is measured in volt ampere, or in short form is VA, to distinguish it from the average or real power, which is P, which is measured in watt. Okay, so the equation here will relate the average power and the apparent power. So since we know that the apparent power is just a product of the VRMS, IRMS, so we can write down the average power equation in apparent power term, which is equal to F cos theta V minus theta I. And here also, we would like to introduce what we call the power factor. So the power factor here is cos theta V minus theta I. So what is the power factor? So the power factor is the cosine of the phase difference between the voltage and the current. And it's also the cosine of the angle of the load impedance. Meaning that the load impedance, for example, if your load, okay, is theta, so this theta also, the cosine of this theta also is referred as the power factor. Okay, and based on the relationship between average power and the apparent power, so the power factor, which is cos theta b minus theta I, or sometimes we also write down as PF, meaning that it is a power factor. So it can be just calculated by using these equations. So there are three ways on how to calculate the power factor. The first one is to get the difference between the voltage and current phase angle. The second one is by looking at the load impedance value. And the third one is by using this relationship. So the power factor is equal to P over the apparent power. And sometimes also this power factor is the information that inside the power factor is very crucial and very important, because it can be also used to show what type of the load without knowing exactly what is the circuit. Okay, so the power factor so this is actually the voltage and current in phasor form, and as you can see here, the difference, the voltage is actually leading the current, or sometimes also normally we call this one current is lagging voltage. So the phase difference is theta v minus theta I should be positive. Okay, so should be positive, meaning that it is actually inductive load. It is actually it shows us that the circuit is actually an inductive load. Okay, and this is actually this type of load will actually produce what we call the lagging power factor. For the capacitive load, so this is the relationship, the phasor diagram between the current and the voltage. And as you can see here, the current is leading the voltage. So the difference between theta V and theta I is negative theta. Okay, so this will indicate that the circuit is a capacitive circuit, and the power factor is called a leading power factor. And for a circuit that there is no phase difference between the voltage and the current, as can be seen here. So this shows that the circuit is actually a purely resistive load. Okay, so meaning that when there is no phase difference, meaning that the theta is 0, so the cosine of the theta, which is 0 degrees, so it's equal to 1, meaning that you have what is called a unity power factor. So just for a summary, so this is the table that shows the relationship between the power factor, okay, angle, and also the power and also the inductive power. For a purely resistive load circuit, so the angle difference is 0, so meaning that the power factor is 1. And so the only existed power is average power only, not Q. Okay, and if your circuit is a purely reactive, so meaning that either L or C. For example, if your circuit is purely L, so your theta V minus theta I will be positive 90 degrees. Okay, and so the power factor will become 0 because cos 90 degrees is 0. Okay, so there is no real power consumed by the circuit. Okay, and if your circuit is if your circuit is purely capacitive, okay, so your angle theta B minus theta I is negative 90 degrees, and the power factor is also 0, okay, and the average power consumed by this circuit is also 0. Okay, and this is if your circuit contains either resistive, meaning that it contains either resistive load or inductive load. For example, inductive load, meaning that your circuit contains R and connected with L. So this one we call inductive load. So your different angle will be positive, okay, and your power factor is lagging power factor. But if your circuit is capacitive load, meaning that you have a resistor and also a resistor and connected with a capacitor here, so meaning that your phase difference will be negative and the power factor is leading. And this is also the summary. So for the first equation here and the second equation for the Q, okay, so depending on the load on the element of the circuit can be in either positive or negative, okay, and the apparent power is actually the magnitude of the voltage multiplied with the magnitude of the current, and the unit is voltage ampere, or short form is VA.